Here we're going to be looking at another Jacobian problem. We've already looked at one, but this one's a little bit more tricky. It's a bit weirder with x plus y's and the exponentials. So obviously with a Jacobian problem, we're looking to try and get it into a form which looks like this. Let's say dp over dx, dp over dy, dq over dx, and dq over dy. So it's meant to look like and it's meant to look like this. So if I get p to equal x squared y e x plus y, and q to be, so p is this and q is this, y plus x e x squared y. So now let's start by differentiating p and getting dp by dx. Now we can instantaneously see that we need to use the product rule in here, a bit of chain rule. So if we let u equal x squared y and v equals e x plus y, let's do du by dx, you're going to get 2xy. dv by dx would be, well, if you let t equal x plus y and you do dt by dx, then you're just going to get 1. So it would actually just be exactly the same. So this differentiated, it just becomes itself. And then we'll then do u dv dx plus v du dx. So you're going to get x squared y e x plus y plus 2xy e x plus y. This can be simplified by taking an x, a y, and an e to the power x plus y out. So you're going to have x, y, e, x plus y. And you're going to have an x, and you're going to have a 2. So that is my dp dx. Let's now work on dp dy. dp dy is going to be exactly the same. Obviously we have to use the product rule, so we're going to do u equals x squared y, so du over dy will be x squared, and let's let v equal e x plus y, dv over dy. It's exactly the same using the chain rule. We substitute t equals x plus y. X plus y differentiated would be 1 plus nothing, because x is obviously a constant, so it would be exactly the same. It would be ex plus y. We use the product rule now. We multiply u by dv dy plus du dy by v, and you're going to get x squared y e x plus y plus x squared e x plus y. And this can obviously be simplified by getting x squared e x plus y out, and you're going to get y plus 1. So that is my dp dy. Now let's do dq by dx. So as you can see from the problem before, there wasn't so much product rule, chain rule being used continually. This is quite tricky. Every single component you can see here has an x and y in both, so having to do use product rule in both dp dx and dp dy. In dq dx, you can see that the first component here doesn't have any x terms, but the second component has an x term in both, so I'm going to have to use the product rule here. So let's let u equal x and v equal e to the power x squared y. I'm going to do this in full in chain rule, just in case you guys are a bit weak at this. So du over dx is 1. Dv over dx, let's let t equal x squared y. Let's do dt over dx, which is 2xy. And let's now do, so obviously v equals e to the t. dv by dt will be e to the t. dv by dt multiplied by dt over dx cancels out your x terms. Whoops, dt by dx. dt's cancel out, giving me my dv dx, which is what I want in my product rule. And now that's going to be this multiplied by this, which is 2xy. Now t equals x squared y. So I've got my dv dx, and now I use my product rules going across. So would be let's just put a little box here, I'll say. So now we're going to get u dv dx, which is 2x squared y e x squared y plus v times du dx e x squared y. So for now this, I can again simplify it out, pull out my e to the power x squared y term, x squared y, let's pull that out and get 2x squared y plus 1. So as you can see here, that is my dq by dx. Let me now do my dq by dy. Sorry, let me just find that. So dq by dy on this would be y plus x e x squared y. So now I don't have to use the product rule here at all, because there is not, if this was x y e to the power x squared y, then we have a y term here and a y term here. You have to use the product rule. Instead I can just do a direct differential on this, which would be 1 plus, because y differentiated is 1, holding the x constant, and using the chain rule here would be actually, do you know what, I'm going to use the chain rule here properly. T, let's just ignore this. Let's let t equal x squared y. Therefore, dt by dy would be x squared. And let's let v equal e to the t. dv by dt is e to the t. Multiply dt dy by dv dt cancels out my dt's. I get dv dy. So I'll get x squared. Oh, sorry, let's put an x in here, because obviously remember we have an x here. So x et dv dt is x et. X squared multiplied by x e to the power x squared y, which would be x cubed e x squared y. And then obviously we need to differentiate this first part, which is 1 plus x cubed e x squared y. So here we have dq by dy. Now finally, let's get it all in there. So we figured out what dp dx is, which is xy e x plus y from here, all multiplied by x plus 2. So obviously I'm filling out this now, dp dx, dp dy, dq dx, dq dy. We know that dp dy is this coming up here, so it'll be, let's put a little comma there, x squared e x plus y, y plus 1. And then dq dx, which is going to go down here, which is e x squared y, 2x squared y plus 1. And then finally, oh no, wait, we're up here, aren't we? Finally, this little value, 1 plus x cubed e x squared y. And that's my answer. You might also see this written in a different form. Now this is just the, if you got this, then you can just kind of turn off the video, you don't really need to carry on anymore. But you might also see this written as xy exponential x plus y, x plus 2, and then you'll have x squared exponential x plus y, y plus 1. exponential x squared y, 2x squared y plus 1, 1 plus x cubed exponential x squared y. So do you see how all I've done right here is change the e's into actually writing exp, sorry. Sometimes they write this in the answer booklets. It's entirely up to you, but both of these is right for this question.